if it is of a degree 2, then in one iteration only you will get a convergence. But if it is more than 2, then they are all the local search methods. So that, but unfortunately, they do not give you assurance of a global or a convergence. So if you use sequential method and by mistake or somehow that most recent inputs which are coming to your network uh, either not available because of some reasons, faulty sensors, faulty actuators, and are not available, or somehow they are not interpreted in a correct way, then entire your learning or processing or education may take you to the divergence. And that is something that one need to take care of. So if your database is uh, I should put it in a way that say if it is unsupervised sort of learning and evolving database, then you can talk about the sequential things. But if it is not, then there is nothing bad to go with the traditional batch processing, because ultimately it may take time. But so because of the advent of some faster GPUs, correct, that batch processing also may give you real-time operations. So that one can work. The another thing that you can ultimately give it in way back in 90s, that is that maximizing the information content in this sort of learning. Now, what we mean by maximizing the information content. So maximizing information thing is just like that. Say, whenever we teach our students, this paradigm says that we should teach students so that largest training error results. Now, at the first glance, that layman may think this is not correct. That training should not be in a way that results in the largest training error, or in the another way, if you want to see that samples that we are presenting are radically different than the earlier samples, then people may argue that what is the fun of having then last samples. But friends, this really works. Both the things are correct in their own way. And uh, largest training error result, it is just like that. Say that whenever we start syllabus contents, we just give an overview that these all are the difficult ingredients which are supposed to come during the semester. So giving it a hint that student may think that what is supposed to come in the entire course duration, and maybe that mentally prepared, and hence may help him or her to gauge the things well. So the exactly the same things happen with training these samples also. So what happens that larger training error are in a way good to us, because they help us uh, to gauge the things that in what different subspaces our data is moving, and that having at least rough idea about all subspaces will ultimately in long run will help us to train the network faster and sufficient enough. So the second one that also goes with that samples which are already learned are learned. So rather than repeating the same things, that we should learn that radically different things, so that what altogether the system has to teach are told in the beginning itself, so that at the later part when we are little tired, when we are little tired with our motivation is that ultimately we need to search for the more of a weight space. So that means that weight space that initially being tuned to the larger extent, and later it may help us. People have talked with the emphasized way also. So emphasize way, that means that always that you start with this, then do this, then do this, and then do this. That Lucan himself in 93 paper that has said that this is not the best way. We shall see it in the next topic also, that why this does not contain. But believe me, friends, maximizing the information, that is just with the traditional that theory knowledge, that information that inversely is proportional to the probability of an event. So that larger the probability, there is no newness in the content, and pausing the newness in the content of a training itself is a good training. So then rather than emphasized way, the another thing is that say the pattern which are that we are presenting to the network should be posed in a randomized way. Now again the people may get that why randomized way. Say the mean is that say you just maybe that first time we take an iteration that pattern number 1 2 3 4 5 6 till n, and then maybe that 6 3 2 10 15 12 and so and so forth. So maybe some random order may improve the ultimate training of a network. So these sort of things generally been taken care by when we rely on the some toolbox, even the Python inherent programming or that even MATLAB toolbox. I think these things already been taken care of. Regarding the maximizing the information content, that I think that we had uh, given it in one of our papers in 2011, and those who are closely working with communication, for them this is the uh, thing that may be known to you, correct? So that one has to in order to maximizing the information content, we need to have a balancing between heterogeneity and homogeneity. With this heterogeneity and homogeneity, what I mean that say for example that we talk about three input binary, three three input binary classifications. So we know that it is supposed to be from 000 to 001 010 to 111. Correct. Now heterogeneity says that say that if you see closely that 000 says something, then 001 010 is altogether different thing, 110 is also different thing, and 111 is also different thing. So we are in in a way we are trying to accommodate all subspace of a given total space which is available for the training. So heterogeneity says that whenever we give the inputs to train the network should be extracted sufficiently from the all subspaces, then and then your training will be better. The another one that is that homogeneity. Now say those who are believing that experimental training or some heuristic training works well, so this is the answer to them that they do not generally maintain the homogeneity. So some of the space we knowingly or unknowingly just train too much, and then that some of the space that remains untrained. So my submission would be that just like that subspace that we are dividing 000 to 111, that clearly maintains heterogeneity because for each individual training pairs there is sufficient heterogeneity, that is a difference. At the same time, if you see that when we consider it as a data space 000 to 111, they all are being crafted only once. There is no undue advantage that 111 is being trained twice or 100 is being trained thrice, and some of the subspace is not trained at all. So when you are talking with that crafting your data for the training purpose, you should craft it in a way that if some data set is available, then you should sample from each of the different heterogeneous domain, keeping the homogeneity. Then and then your network will be trained in the best possible way. Correct. Uh, Regarding the activation function, that also there is a dilemma because say that uh, uh, obviously it is fact that learning is better when that some of the that rather than symmetric some anti-symmetric functions are being used, but this does not work always. Say because say those who have started already or those who have used already the deep neural networks, you must have seen that people are talking about either the that ReLU function or leaky ReLU function or some uh, 10-6 sort of things, correct? But incidentally, my submission here would be that don't fall into love of any specific activation functions, because that one thing is very sure, that we are using activation function at all to take an advantage that in the existing domain, whatever is available to us is not sufficient enough for classification or the prediction, and hence we want to take it to some data space from which this distinction is available. So keeping that in mind, any transfer function or any activation function will work. The problem is that we need to visualize that in what subspace our training data set is available, and where we want to get it tuned so that prediction or the classification is available. So that my submission would be, you better try all of them one after another in a given network. And if your data range is lying, then nothing best than that the simple even linear with some slope. Because say when we talk about the sigmoidal function, we know that it is working best between the range of zeros and one once we have normalized the data. But it operations becomes little tricky when we are talking about the saturation points. In saturation point, it loses the discrimination, and hence only we go for, rather than sigmoidal function, we go for the antisymmetric functions like 10-6. So 10-6, it is available in first quadrant and third quadrant. So it is just like a S curve, but it gives us the double the space to travel than earlier available with the sigmoidal function. So my submission would be that we should think about that in what model or in what way our inputs are available. If they are in binary, then sigmoidal should work. If they are available in bipolar way, yeah, then even the 10-6 should work. Then there is no point in going with simple sigmoidal function. If bipolar data is there, one has to use some antisymmetric functions. So that may increase the study of your this sort of things. Another that parameter that we have worked, that whenever uh, target values are available, we should choose it that they fall within the range which are the little less than the maximum of the activation functions. So otherwise network will tend to drive the free parameters to infinitely slowing down the learning process. Now this is, I think that this you should take into account that say that gradient descent, that gradient descent method is very nice. So if you have got no clue about where to take your data to the convergence, gradient descent in initial stage works with wonders. It may half and half. So in the couple of iterations, out of the entire range, you may be there with around 10 or 15 percentage of your final value. But then because of the nature of the network, that will create a catastrophic, and it will be very slow then if you continue with the same network. So my submission would be that one has to be little careful while targeting with these target values, and it should fall within the certain range of the free parameters, then and then that can be used. Another input paradigm that one should use while applying the machine learning technique, that is that normalization of the input. Now, why normalization? I think that as all our faculties you must be knowing, because that this concept must have come in a way or another while teaching to students. The thing is that say that in order to reduce the undue weightage to some of the input values, we are using the normalization. Correct? And that we do explain with the traditional, I think that analogies which are available. But when we do the normalization, with normalization one should use, whether one should use the normalization which is given with the MATLAB toolbox, or some which is given by the Python, or we should do something else. And my submission would be again that Normalization should be done in a way that mean value is ideally tending towards the zero, and uh, or that it is mean value is small compared to the standard deviation, so that may work. So uh, if you see the literature, around 5 7 methods are already available for the normalization. So unlike sticking to the something which is given to with the toolbox, you may try to work with few of them before fixing the network. Correct. All input variables are supposed to be uncorrelated. Correct. So this is the fundamental thing, because see, otherwise what we are doing that we are just trying to bias some of the inputs, and we are just trying to avoid knowingly or unknowingly some fellow parameter which is genuine, but we do not give enough space for that growing parameter to put its emergence, so that we are not we are stopping someone from growing. So that's why that once we have decided that we are going with 12 parameters or 13 parameters or 6 parameters, all 6 parameters should be used wisely with sufficient weightage. I'm not saying equal, but with the sufficient weightage, ideally with the uncorrelated, that is with the equal weightage in our data set then onwards. Otherwise, you don't use it. This is again one of the a good way to look around the problem domain itself. That is from where to initialize. What is a good choice? We should start with some larger synaptic weights. We should start with some low synaptic weights. Shall we have some uniform distribution or all zeros? Something that people generally say, again with the computational methods, those who have used that, initially we were always asked that you start with all vectors zero. So, dear friends, that if you do not know, then answer lies that starting with all zero may give a catastrophic effect in machine learning algorithms implementations. Just to give you some analogy, that it may be that say that you are starting with some of say maybe Pune railway station, and from Pune railway station you just search for some place. I am not familiar with the geographies, but maybe it's at Gandhi Nagar or Nehru Nagar, because these are the common names, or Tilak Nagar, maybe. So that if you start with that and ask that taxi driver or a rickshaw fellow that I want to reach Gandhi Nagar or Nehru Nagar or Tilak Nagar or some other Ambedkar Nagar, then whatever that in local region that place is available will lead you to that place. If you ask another time some another fellow without explicitly defining it, that the same fellow will again take you to the thing, same things. So n number of time you execute the thing with some sort of without explicit specification, and all the time you will you may end up with some wrong results. So exactly the same things happens, as I said told you that say these ultimately methods are that higher level all learning algorithms and based on some Newtonian methods, but they are only locally convergibles. So if you start with all zero or with some same initial values, then ultimately we are we are putting ourselves into this trap. We always try with the same things, and my dear friends, always will end up with the same erroneous location. So all zero is a very bad choice. uh, Similarly, larger synaptic weights may not also work, because say larger synaptic weights, that means that we are trying to say that ultimately we are supposed to learn weights and biases. So why not to keep them at larger? But say friends, when we take them at a larger value, what we are doing that we are confining it to work around the saturation regions. And when we work with the saturation regions, they may create some another problem. So these sort of activation functions also do not work well towards the saturation, and hence the learning will not be or maybe that it may be very bad learning. Low synaptic weights will take a very long points, very long time, or even that synaptic weights being low, we may, I think that this terminology may be known that saddle point. So saddle point ultimately talks about local minima. So the trapping down the local minima with the low synaptic weights always is a problematic case. And then with the uniform distribution, maybe that I was talking about the homogeneity and heterogeneity. So non zero with having the mean equal to zero and variance equal to the reciprocal of the number, that one may try for and maybe work. But say that my submission would be that say you should try with all options before that taking a stand that I shall use this one. Correct. Uh, Again say this, you can see that all these theorems that I am using are always available in literature over the years, and that inherently with some other names, now we are using it even in deep neural networks. The same happens with this another friend as well. So this is regarding the learning rate. Now ideally that say that people may argue that sir you are talking about all inputs being given equal weightage, so as supposed to be with all neurons being trained with equal learning rate. Is it that correct? The unfortunate answer, it is not. And that without explicit care, that if you see that all that recent days winners of deep neural network, that different I am talking about VGG, and then other networks which are predominantly available, they all are supposed to take advantage of what I am trying to say. Now they are just given some uh, different names, but this essence were available in the literature over the years. Not equal to all neurons, not even layer all neurons should be given equal learning rates. That actually depends on the whatever is the requirement. Then another option is that is it supposed to be random? Now, while we are taking as a random that say as I am always advocating that we should always see that entire chunk before applying, and random may be the good choice. But when we are taking about the random and training it just once may not work. So when we are taking random as a learning rate, then we should obviously talk about that with the given rate, some couple of more learning rates, couple of low learning rate, and we don't know that at what learning rate we can get some good results. Correct. So that is also available. Theories now suggest that different for different layers, and that is exactly being nowadays work with the deep neural networks. That more generalized learning happens with the initial layers, and refined sort of classification or tuning that happens with the later part. So whenever we want to adapt some existing deep neural network sort of thing, my submission would be that you take first uh, few layers of the network, and then rest you may tune at your own. So that may somehow give you some better results. So Lucan also suggested that learning rate should be inversely proportional to the square root of the synaptic weights of the neuron. So this is again one of the heuristics only. And my submission would be that just like others, this also in literature way back in late 80s, correct? So one may work around this. Because of the time constraints that say because that I have given some discussions on this one, so I could not talk about some of the parameters which you may find with some any standard text. That is that what should be the number of hidden neurons. Say that when we are specifically when we are talking about the thin networks, that how many hidden neurons should be there. So MATLAB Toolbox has suggested that you take input, you take output, aggregate both, divide by 2, and that may work. Even people may start with some random number and then go a little bit up or towards the lower sides. What should be the number of layers? Now again, there is a uh, there is always a debate that how many layers should be used. That typical nowadays people are talking about in tens of neuron the layers. But my submission would be if it is a typical classification problem, even single hidden layer is sufficient for the training, and one should use it. uh, Regarding manufacturing data, that people have given now the different names like that some GAN network and handcrafted networks and some another. Those all things are also available in literature, and one may refer even Raj Sekharan or Simon Hekin or even Duda or any other pattern recognition text. Stopping criteria is also that whether one has to stop with some minimum mean square error or some number of epochs or number of some iterations or some time or some other parameter. So one may take as one's choice. So these are the simple things which are available in literature, and hence I am not talking in details. Regarding now our network that we have trained, that we kept parameters to 13, that all were normalized between 0 to 1. But before that also we not in this problem but in other problems, we should also think about that how different inputs are correlated to each other, if they are correlated. Then also just to give you some simple example, that if you are talking about some fuzzy based system which is working for the uh, uh, how your headlights should glow, then in that case the distance lesser with the opposite car is that lesser the distance is a more critical one. But if we see the intensity of a light, more the light is more critical. So both the inputs are contradicting to each other. So my submission would be that if you blindly use them, again we are supposed to commit a lot of error. So you should synergize the inputs. Either one should be maximized or the another one should be minimized before applying. So it is 1 by X you can do, and you can work around. In this case, for this problem, there was no such realization. Uh, we executed the forward pass and then decided to go with the MSC as an error. And some of the traditional available steps that SSC and MSC. So we went for MSC as an input, and we could tune our network. So the rest is, I think, it is very ordinary steps that is available with the literature also. So I think with SVM, more or less all people are available and knowledgeable. So traditionally been used for two categories, but we can compare by one to one. And now the E class, that M class classifier SVM is also available. So the traditionally what it does that given M samples, M training pairs, that X1, Y1 to XM, YM, ultimately we try to fit in the function this. And once this function is available, then we can use it for the classification. And the gist is that, so this is the difference. So either that this is your training, so this is your training estimated model, and these are the actual. So actual minus that trained, or trained minus actual, that both whatever that you do the sum, that it should be less than or equal to some epsilon value, the threshold that what you like. So ideally it should be zero. If you are having that very sure that the whatever the inputs are that are exactly been bifurcatable, then that works. But otherwise with epsilon value, we can ensure that this holds. So this is a typical unsupervised, or rather that unconstrained problem, but uh, that may not work. So that ultimately we want to that maximize this margin 1 by W square. So it is another way that we can say that minimizing the that second norm of weight vector ultimately will be able to maximize this value, correct? So that it is being computed as a lost function. You know that 1 by 2 is just being added to just negate that 2 that is coming by the differentiation. So that subject to this is a traditional one, but as we know that traditional one generally does not work, so we may need to take the help of the slack variables, and with the slack variables that works around with the typical Lagrangian problem, correct? So that device optimization, that is we can say that it is a constraint optimization problem, that is with this original unconstrained problem and been supplemented with this Lagrangian, that is a cost factor with this slack parameter. So that can work better for the training with these conditions. One may work with KNN approach also, which is also traditionally available in literature. So what we do that intuitively we select that how much closeness we want to justify. So that pattern A and pattern B, one of them may be the reference one, and this may be the incoming, and that we can decide. And that depending upon the closeness, what this distribution is there, that is available to us. And again, in this case, also some heuristics are available that k less than or equal to square root of n, where n being the number of training samples. So that many that exemplars will be available to you as a output in near vicinity, and one may work. Correct. Uh, Regarding the simulations that we carried out in this case, so that again with the Cleveland data set, that total data set was around 294. So we had some skewed training, 270, and then we used forward back propagation. So training function, you can see that we have used train GDA, so that is a gradient descent with adaptation. So in our case, it worked better. Adaptation learning function also we use gradient descent with momentum. So adding a momentum, we could find out that that worked better. So if you see it closely with that MATLAB toolbox or some that Python script, they typically use Liverword Markov method. But as I'm saying that I normally do not blindly choose. In our problem, this combination worked better for us, so we have taken it. Correct. So that we kept hidden neurons 15. So actually we started with 10, we gradually moved to 10, 12, 14, 15 till 20, but 15 gave us the best results. So that larger always does not work into neural network paradigm. So taken hint from that, we then took in between, for which we used to get some good results. That is 15. So that was that when it was trained once in MATLAB toolbox, this structure was emerged. While experimenting with the SVM based method, we took a mean and then 3 sigma on the either sides, and we took them as a cost function and trained. And these are some of the results. So we can see that we had just in for the presentation sake, I have just presented into the only few of the data from the Cleveland record numbers. So record number 3, if you can see that desired was 0, and KNN could not give the 0 value. From some other records, if you see that record number 215, 218, 219, that MLR does not work. Even BPNN also did not work. But uh, this in these particular studies, we could find out that more or less either the naive based or the SVM based paradigm that worked, and even that I had much confidence with the SVM. So that when it was tried with some other databases also, that SVM paradigm gradually worked better for the classification, and that classification accuracy, if you can see that for the MLR, these are all methods that we implemented: MLR, BPNN, KNN, naive Bayes, and SVM. That for MLR, obvious because of obvious reasons, the accuracy was 65. KNN could give 70%. BPNN almost 95, 96%. But for the naive and SVM, we could achieve and better that literature results having around 100% accuracy. So this is our comparison with literature. So in literature, again, some papers were available with some random forest and some BPNN networks and naive Bayes. So for in order to compare apple with apple, we use the same data sets, and taking that whatever is mentioned, these are the success rate. So again, you can see that SVM and naive Bayes perpetually gives some better answers. So I think summary I have already talked. So it is around 10 or so minutes left. So some queries are there, then I may take up. Yes, Professor Pranav, I think I am done with my part.
Yes, sir. Yes, sir. Thank you, sir.
And, and I hope that participants are not felt sleepy because there were lot many things to be discussed. So I just continued with the monologue with your permission at one midpoint. But
Yes, sir.
I
We
would
have
like to,
we have couple of questions.
yes, please.
Yeah. So the first question is, can you throw some light on benefits on of normalization?
Okay. Okay. So say normalization, as I was pointing out that point. Say for example, say let us take only two inputs. One is having some weight in tons, so that input range may be varying from 1 ton to 1.5. So we know that 1 to 1.5 ton is more in a traditional way of linguistic values. But when we give it as an input, it is just a numerical value. So it just varies 1 to 1.5. At the same time, say for example, some another parameter that is in cubic centimeter, and that varies from 10,000 to 1 lakh. Correct? Now let us assume that weights for the network for W1 is 1 and W2 is also 1, and we are driving some output. Correct? So now when we keep the second one, that is that volumetric data constant, maybe at 10,000 or 1 lakh, it does not make, and change the entire value of input number 1 from 1 to 1.5, then obviously that it will be 10,001 to 10,000 1.5. So so there is no apparently effect of input number 1, which we have considered as a one of the critical inputs. I hope that I am making some point. Input number 1 is varying from 1 to 1.5. Input number 2 is varying from 10,000 to 1 lakh. I am just taking the lower limit 10,000, so that if the weight values are 1 1, then we are talking about 10,000 to 10,001. That is a output change. So output does not have any effect of entire range of manipulating with the input number 1. At the same time, if you keep input 1 constant and vary with the input number 2, that varies from 10,000 to 1 lakh. So 1 and 10,000, so that is 10,001. Another extreme for the second input, that is 1 lakh. So the output will be varying from 10,001 to 1 lakh 1. So there is a huge effect. So it will have a prima facie effect that input 2 is extremely important and input 1 is not important at all if you directly use it. So normalization, what in plain text assumes that everything is being normalized to some values, maybe 0 to 1, or maybe on a scale of quantification values, that is 1, 2, 3, 4. So this to this range value, we just assume that it is 1. This to this range, it is 2. So we try to reduce that mismatch between the input data ranges by doing the normalization.
Yes,
So
sir.
once normalization is done, that input 1 will have a same effect in drawing the output. The input 2, which is having a maximum value of 1 lakh. So if every parameter is being divided by 1 lakh, again it will be having the range between 0 to 1. So once given to the network, as I said, that all are our essential input parameters and prima facie are all equal important. So due weightage only considered effectively if we normalize them, otherwise not.
Yes, sir. Thank you, sir. The next question is, recently ReLU activation function is commonly used. Uh,
Correct.
can we use it in heart disease analysis?
Uh, See, as I told you, say that there is nothing bad in using ReLU as an intermediate or even for the output. But my submission to all Python lovers would be that say don't fall into love with some of the parameters as it is mentioned in literature. The reason being that say Relu or Ricky Relu that you see that they also tend to give you some hard jump in between. So my submission is that if you want to take your input value to some another subspace region, then whatever is more advantageous, you take that. Say for the decision last stage, obviously because of that this sort of nature, ReLU works better and hence people tend to use it. But my submission is just that you before utilizing it, just cross check it. Literature have many times used it, and maybe that out of 10 times 9 times it has been narrated that ReLU works better, or sometimes that people tend to use leaky ReLU also works better. But my submission is that still you just check the other ones that maybe in your case it may work other way. In my case, we stick to tensing, and tensing work better.
Yes, sir. With this, we are at the end of the session. We will conclude the session with vote of thanks. I, Pranav Chipalkatti, on behalf of JSPM's Rajarshi Shahu College of Engineering, Department of Electronics and Telecommunication, heartily thank Dr. Maulin Joshi for sparing his time and sharing his experience with us. He has enlightened us with his motivational work, literature, then MLR model for heart disease diagnosis, then neural network based model for heart disease diagnosis, and finally the SVR based model for the same. Thank you. Thanks a lot, sir, for sharing your time and experience with us.
So it was my pleasure to join with you all people, and I hope that at least I could ignite some of the minds to work in the domain, or to work cautiously in the domain when the many things are readily available. Correct. So that sometimes hurts. That says that we should not use it blindly. That is what my essence of this talk was.
Yes, sir. Thanks a lot.
Okay. Thanks, Professor Pranav.
Yeah.
Yeah. I'm just closing this.
Yes, sir. Yes. Bisikar ma'am. Uh, Participants are requested to remain in the meeting. The next session will start at 11:40 sharp.
Thanks.